Hey guys, it's Vadim with Max Tech, and as you already know, Apple broke the tech side of the internet with the new 14 and 16-inch MacBook Pros with their controversial thick boy redesign, and of course, the notch that nobody was expecting. But in reality, the real shocker comes down to Apple's new M1 Pro and M1 Max chips, which are blowing the minds of basically everyone in the engineering world and the tech space in general for various different reasons, which I'm gonna dive deep into in this video, which is 100% focused on these new chips. So what I'm gonna do is explain everything you need to know about them, including how they work and what makes them so special compared to any other computer chip on the market. So without further ado, let's get right into the basics. The M1 Pro chip is basically a souped up version of the M1 chip from last year, packing in twice the number of performance cores and GPU cores while ditching 2 of the efficiency cores, giving us a 10-core CPU and 16-core GPU on the M1 Pro. And speaking of those cores, the Apple Tree on Twitter, who by the way wrote this wonderful article, has confirmed that the new chips are in fact based directly on the cores from the M1 chip. And if that sounds obvious, I previously speculated that Apple would base these cores on the new ones in the iPhone 13's A15 chip, since basically all of those cores are faster across the board than the cores in the M1. But as you can see, Apple rated the M1 Pro's GPU cores at 5.2 teraflops of performance, which is exactly double the performance of the M1's 2.6 teraflops, confirming that they're the same exact cores. On top of that, I speculated that Apple would pack in the A15 chip's faster neural engine that can run over 15 trillion operations per second, but nope, Apple showed that the one in the M1 Pro is using the M1 chip's neural engine with 11 teraflops of performance. So this basically confirms a few of the other details about the M1 Pro and M1 Max chips. We know that they're not built on the latest 5nm plus process node from TSMC, it's just the regular 5nm, and we also know that the video encoders and decoders are most likely identical to the ones in the regular M1 chip. But thankfully, Apple did toss in some brand new ProRes encoders and decoders, which is, by the way, a world first from Apple. No other computer on the market can do this, not even the Mac Pro with the dedicated afterburner card, since it can only decode ProRes. Now going back to the chip, it of course packs dedicated Thunderbolt 4 controllers right inside of the chip package, as well as many other things like the secure enclave for security, an image signal processor for the webcam, dedicated caches, machine learning accelerators, and more. But let's go ahead and dig deeper into the M1 Pro chip by referring to AnandTech's article on this topic, where Andre provided a labeled graphic of the chip itself. Here, he pointed out that Apple is now using 2 blocks of SoC cache, which serves the entire chip to amplify bandwidth, reduce latency, and improve power efficiency. And apparently, this new chip looks like it's using double the amount of SoC cache, 32 megabytes, compared to 16 on the M1 chip. Now, as far as the RAM, Apple is using unified memory, which is making these chips extremely special. So let me explain how it all works. Traditional RAM that you find in many x86-based computers is always separated from the main CPU and GPU chips, which adds extra latency since data that needs processing has to travel through electrical circuits in the main logic board. So to perform a graphically based task, the CPU has to copy data to the RAM, and then that data gets copied to the GPU for processing. And once it's finished, the data gets copied back to the RAM again, and then copied from the RAM to the CPU so that it can do its part of the processing before repeating the cycle all over again and again. But with Apple's chips, the memory is built directly into the main package with the CPU and the GPU, and since it's unified memory, both the CPU and the GPU can have access and work on the data at the same time without having to copy it back and forth, and with greatly reduced latency since it's all right there in one package. So to make this as simple as possible, imagine that there are two painters. One is called the CPU sitting over here, and one is called the GPU over here, and they have a single canvas in the middle. For them to paint and work on it, they have to hand it back and forth to basically process and finish up the painting. But with Apple's unified memory, the CPU sitting right here and the GPU is also right here, and they're both painting on the canvas at the same time. So as you can see in this representation of the M1 Pro chip, you have a dedicated RAM chip on each side of the M1 Pro. And each RAM chip also has its own dedicated 128-bit memory bus for that data to travel through, which effectively means that the M1 Pro has a 256-bit memory bus, which allows up to 200 gigabytes per second of memory bandwidth, which is extremely impressive. And based on Andre's calculations, this means that the RAM in the M1 Pro is most likely LPDDR5 RAM that runs at up to around 6400 megahertz, which is much faster than the 4266 megahertz RAM in the original M1. But making it even better, the way that Apple set all of it up means that the RAM operates through 16 channels. 8 channels on the left side and 8 on the right side, which is something that's completely unheard of in the computer space. But before I explain why this is such a huge deal, I want to ask you guys to hit that subscribe button below to help us reach 1 million subs before the end of the year, and be sure to use the M1 Pro promo code to get 20% off on all of our merch, including our new M1 Pro/Max Sharpie Edition shirt down in the merch shelf below. Getting back to those crazy 16 channels of RAM, the beautiful thing is that you get the full 16 channels regardless of whether you choose the 16 gigabyte or 32 gig RAM option, since both versions still use a full RAM chip on each side of the M1 Pro. The difference is in the use of either 8 or 16 gig RAM chips. But now, let me explain why having 16 channel memory is so impressive. Every single CPU that Intel currently sells uses dual channel memory. Yes, that's 2 channels compared to 16 on the M1 Pro. So this means that the current 2020 27-inch iMac uses dual channel memory. The 2017 iMac Pro that I wrote this script on uses quad channel memory because of the pro-grade Xeon chip. And our $15,000 Mac Pro actually uses 6 channel memory. And to show you why having more channels is so important, here's a chart showing the photo editing performance using Lightroom Classic. As you can see, the performance improves based on the number of memory channels in the system, and we know this for sure because the iMac Pro is actually faster than the regular iMac, which doesn't make sense because the regular iMac has double the amount of RAM and it has faster CPU performance than the iMac Pro. But because of the dual channel memory limitation, it actually ends up being slower in this raw photo exporting test. And to explain this as practically as possible, you can think of a memory channel as a highway connecting the RAM to the CPU. With only 2 highways, there is going to be a lot of traffic when moving a lot of vehicles or data back and forth. That's why moving up to 4 highways or channels on the iMac Pro improved performance despite actually having a slower CPU, since it freed up all of that traffic. And then of course, it got even better with the Mac Pro's 6-channel memory. So now you can understand why having 16 channels on the M1 Pro chip is such a big deal. But wait, there's more. And get ready for this because I'm about to blow your mind. Everything I just mentioned was for the base M1 Pro chip. So now let's venture into the more expensive M1 Max. This chip is much larger, as you can see in this image, being roughly 75% bigger than the M1 Pro and 3.5 times bigger than the original M1 chip. So what this M1 Max chip does is it basically doubles up on many of the components found in the M1 Pro, including double the GPU cores to make a 32-core GPU, double the SoC cache to make 64 megabytes of cache, which can be used by the entire chip, double the number of RAM chips, as you can see in this graph, 4 of them, and double the number of memory buses to support those RAM chips, making for an incredible 512-bit memory interface, which gives the chip up to 400 gigabytes per second of memory bandwidth. And the craziest thing of all is that the number of memory channels is once again doubled. Yes, the M1 Max chip, regardless of the amount of RAM or GPU cores that you pay for, has 32 channel memory. Now, if that didn't blow your mind, I don't know what else will, because what Apple has achieved is literally an engineering masterpiece, since even the latest EPYC server chips from AMD are still limited to just 8 memory channels. And to put the final cherry on top, because of the unified memory architecture, the RAM is fully accessible by the GPU, meaning that if you bought the model with 64 gigabytes of RAM, you essentially have up to 64 gigs of VRAM for the GPU to make use of. This makes the M1 Max the world's first chip or GPU to come on the market with more than 48 gigs of accessible VRAM, beating out NVIDIA's Quadro RTX 8000 GPU, which sells for $5,500 by itself. But to give you guys a more realistic comparison, the previous top-of-the-line 16-inch MacBook Pro with the 5600M GPU came with only 8 gigs of VRAM, and the current best GPU in any Windows laptop is the 3080 Mobile with up to 16 gigs of VRAM. So you can see why 64 gigs of VRAM on the M1 Max chip is mind-blowing. So with that said, hopefully you learned something new about the M1 Pro and M1 Max chips, and if I just convinced you to order one of them, you can find links to the best deals on the new 14 and 16-inch MacBook Pros down in the description below. And if you enjoyed this video, go ahead and click the circle above to subscribe, because we just ordered 8 of these to test out and make videos on. So thanks for watching, and we'll see you in the next video.